Hello Ian, I have noted the concern that you said that you do not understand the video, and I'm hoping this will give you some light concerning what you're supposed to do. So very quickly, we are going to derive the continuity equation, or what also can be referred to as the equation of continuity in fluid mechanics, or what we call fluid flow. And we are going to start with a pipe, just as the one that you saw in the video, a pipe of different sizes, of varying sizes, something like this. As you can see, the cross-section area at this point is a little different from to the cross-section area at this point. So let's say that the cross-sectional area of this at this point is A1, and the cross-section area at this point is A2. So if you consider a section of the pipe like this, a section of this pipe at this point with length L1, and on the other side also you can consider a cross-sectional area of the pipe, a section of the pipe which is length L2. From what has been defined to us, we've seen that the flow rate, which is given by Q, is given by the volume of water that is passing through a point. Let's say it's through this point, through this section, from this part to this part. What volume of water is passing from this point to this point? That is what we call the volume over time. That is what we call as the flow rate. So if you consider the flow rate at this section, which is Q1, it will be given by volume 1. Let's say the volume of this one is volume 1 over T. We can't have T1 or T2, so we shall have volume 1. But volume is given by area times length, of which our volume 1 will be equal to A1 times L1. So we come back to this equation so that we shall have our Q1 will be given by A1 times L1 over T. But let's look at this L1 over T. Let's separate it like this. Q1 should be given by A1 L1 over T. If we have something like that, if we combine the two like this and have them in brackets, then we shall have, we know that length over time gives you velocity. So in this case, we shall come back to our Q1. Our Q1 will be given by A1 times velocity 1. That is the cross-sectional area at this point multiplied by the velocity of this fluid. At what velocity is it moving at this? At what velocity is the fluid moving at this section of the pipe? So if you perform the same mathematical manipulations in the other section, you realize that Q2 will also be given by the cross-sectional area at this point multiplied by the velocity at which the fluid is flowing with at this point. Now that we are there, we know that the flow rate will not change. The flow rate at this section should be equal to the flow rate at the other section. That's why we have the flow rate at point 1, that is Q1, being equal to the flow rate at point 2, that is Q2. But what is Q1? Q1 is A1 V1. Remember, V is the velocity, which should be equal to Q2, and Q2 is A2 V2. And now this is what we call the equation of continuity. So I hope this is better but this is exactly what has been done in the video. So if you understand this, you can always go back to the video and see if you understand it better. Thank you.